The scariest sound in space isn't a scream. It's a signal that no human ear could ever hear in real life. And when scientists convert it into audio, it reveals something violent enough to shake space-time itself. First, an important truth. Space is essentially a vacuum, so sound waves, pressure waves moving through air, can't travel the way they do on Earth. If you were floating between stars, there would be no audible explosions, no booming engines, no noise, silence. So how can there be a sound in space at all? Because scientists take real data, radio waves, X-ray pulses, or gravitational wave signals, and sonify it. That means they translate those patterns into frequencies humans can hear. The sound is a map, not a microphone recording. And some of these maps are genuinely terrifying, because they represent cosmic events that would destroy our world if they happened nearby. One of the most famous examples is the sonification of a black hole. In 2022, NASA released a sonification based on real data from the supermassive black hole at the center of the Perseus galaxy cluster. The cluster contains hot gas that actually can carry pressure waves, so unlike most of space, that environment allows something similar to sound in a physical sense. Scientists had previously identified ripples in that gas, produced by activity from the central black hole, with an extremely low frequency far below human hearing. By scaling it up into the audible range, you get a deep, haunting tone, often described as a cosmic moan. But the truly scariest sound, in terms of what it represents, comes from gravitational waves. Gravitational waves are ripples in space-time predicted by Einstein and first directly detected in 2015 by LIGO. They're not sound waves in air. They're distortions of distance itself, caused by massive objects accelerating. The most intense sources we've detected are mergers of black holes and neutron stars. When LIGO and Virgo detect a merger, the signal is often converted into audio. You hear a quick rising chirp. That chirp is terrifying because it's the signature of two ultra-dense objects spiraling together at a significant fraction of the speed of light, releasing an enormous amount of energy in a fraction of a second, mostly as gravitational radiation. For brief moments, the power output can exceed the combined light of all the stars in the observable universe, not because it's brighter in light, but because the energy is carried in space-time waves, not photons. Here's what makes it even more unsettling. Those chirps pass through Earth and slightly stretched and squeeze the planet. LIGO detects changes thousands of times smaller than a proton. The scariest part isn't the noise. It's the fact that space-time is not rigid. The universe can ring like a bell, and we're inside it. And the danger angle is real. A black hole merger has to be extremely close to harm Earth directly, because gravitational waves weaken with distance and interact very weakly with matter. But events like neutron star mergers can also produce powerful gamma-ray bursts, jets of high-energy radiation. Point one of those at Earth from close enough range, and it could severely damage the ozone layer and threaten life. That's rare, but not impossible over cosmic time. There's another sound that unsettles scientists for a different reason: fast radio bursts, or FRBs. These are millisecond-long flashes of radio energy coming from distant galaxies. We now know at least some FRBs come from magnetars, highly magnetized neutron stars. In 2020, astronomers linked an FRB-like burst to a magnetar in our own galaxy, confirming magnetars can produce them. When FRB signals are sonified, they become sharp clicks or snaps, like cosmic static, reminding us that extreme physics is happening constantly, all over the universe, and we usually have no warning. So the scariest sound in space depends on what scares you more: the slow, unnatural moan of a black hole stirring hot gas, the sharp crack of an FRB from a collapsed star, or the rising chirp of two black holes colliding and making space-time itself vibrate. Follow for more science that turns mystery into understanding. And tell me, which is more unsettling to you, the idea of a black hole singing, or the fact that space-time can physically ripple through Earth?